Okay, all right. Now in this 10th chapter, that is limits of accuracy, we know so far that we have three most important things. It's the original measurement, which would be given. For example, if we look at example number 1, it says distance of A to B is 300 kilometers. This 300 kilometers is basically your original measurement. Okay. Then it says to nearest 10 kilometers. This was our accuracy. And then we know how to find the error. We used to find the error by doing accuracy divided by time. I'm just giving a quick recap for those who have just joined, and if you guys have forgotten anything, just so we are able to revise the contents quickly. But that was the idea. Now, the question would be of two types here. The examiner can either ask you to find the upper bound of a quantity, or he can ask you to find the lower bound of a quantity. When it would be about the upper bound, you need to find the maximum possible value. Okay. And when it would be about the lower bound, we will calculate the lowest possible value. The idea is simple. For upper bound, we are adding the error. For lower bound, we were subtracting the error. Okay. So if we talk about the first part of the question, it says, find the upper bound of distance and time. This was distance. This was the original measurement. So original plus error would give us the upper bound. How do we find the error? We used to find the error by doing accuracy by 2. Accuracy was 10. Accuracy is the figure that comes after the word nearest. Okay. For example, if I talk about the accuracy of time, so after nearest, it says nearest hour. So that means 1. When we do not have a number after nearest, that basically means it would be 1. Okay. So it's simple. It's distance. Distance is given, that's 300. For upper bound is 300 plus error, that gave us 305. For time, the original value was given, it was 4. So we did 4 plus the error of time. So it was 1 divided by 2. It gave us 0.5. And we have just added 0.5 because we were talking about the upper bound of time. Similarly, we discussed lower bounds. Okay. Now again, the original figures were given in the question, and since the question was about the lower bound, I just subtracted the error, and this error was actually found by doing accuracy by 2. Okay. Again, this gave me 0.5 when I did 1 divided by 2. Okay. These two parts were simple, and this gives you a good understanding about what exactly happens in case of upper and lower bounds. Okay. Things got complicated when we discussed the third part. The third part was find the upper and lower bounds of speed. Now, speed is the third quantity. You did not have any idea about speed originally. You only had distance and time and their accuracies. You did not have any idea about speed or its error. So we had to do everything according to logic. Upper bound of speed basically meant maximum possible value of speed. That means we need to have the maximum possible numerator and the minimum possible denominator. Okay. Now for distance, we have its lower bound, we had its upper bound. The lower bound was 295, the upper bound was 305. I know that a fraction would be greatest possible when its numerator would be greatest possible and its denominator would be lowest possible. Okay. So since speed is a fraction, in numerator, I just took 305, and in denominator, I took 3.5 because 3.5 was the lower bound of time and 305 was the upper bound of distance, and this gave me 87.1 kilometers per hour. And again, when I had to find the lower bound of speed, that meant I was supposed to find out the lowest possible value of speed. Speed is a fraction. If I talk about fractions, the numerator has to be lowest possible. So I had two options for numerator, 295 and 305. I just wrote 295 because that's the smallest possible option. And if I overall want speed to be lowest possible, time has to be maximum because it is coming in the denominator. So I took time as 4.5, and when I did 295 divided by 4.5, this is what I got. So this was the maximum possible value or the upper bound, and this was the lowest possible value or the lower bound. Anything that's confusing you, feel free to ask me right now. You guys are more than welcome. This is the time that we need to discuss before going to the past paper questions. Ask me as many questions as you feel like. Okay. Yes.
No questions.
Okay. All right. Hassan, Naz, and Hassan Sahal, any questions?
No, ma'am.
Okay. Even if you guys are shy in asking questions, you can just type. I would not even take your name and I would directly explain. Okay. I think things are good with this part. Kabir has just joined, but all this was old content, so I did not, explain it in that much detail. We already know this much content. Okay. Now it's the time to shift to past paper questions. Okay. Let me just go there and then I'll tell you every other thing about it. Okay, yes. So these were some questions which we were discussing in the last class. We were able to do the first parts because that was easy, and the second parts were basically technical. So let's have a look at these questions once again. Okay. The first part was Anil has some sweets with a mass of 600 grams. This was your original quantity, correct to the nearest 1000 grams. So this was original. This is your accuracy. First of all, we need to find the error by doing accuracy divided by 2. Accuracy was 10. So 10 divided by 2 gave me plus minus 5. We always write down error as plus minus 5 because at times we are adding for upper bound and then we are subtracting for lower bound. So this depends. Error is always with plus minus sign. Okay. Now, we had to find out the lower bound. For lower bound, you need to do original minus error. Original was 600 minus 5, and that gave me 595 grams. So this was the answer. Okay. Always remember, for lower bound, we do original minus error. And this was an easy example. This is basically a past paper question. So the first part was easy. And that is why it was only for 1 mark. Okay. All right. Let's talk about the second part, or the more important or the complicated part. Now it says, Anil sells the sweets in small portions. Each portion has a mass of 25 grams, correct to the nearest gram. He sells 10 portions of the sweets. Calculate the lower bound of the mass of sweets remaining. Okay, we need to understand the scenario. This is not a straightforward question. Just like the previous past paper question, when we had to find out speed, that was not straightforward. So again, the idea is same. You are supposed to find out the lower bound of the...
Your voice, I can't hear it.
Yes, can you hear me now?
Yes, ma'am.
Okay, all right, okay. So basically we were discussing the second part of this question, and here things are a bit complicated. It said calculate the lower bound of the mass of sweets remaining. Okay, so we need to find out the mass of remaining sweets, but it has to be the lower bound, the lowest possible value. Let's understand the scenario. In total, we had 600 grams of mass for the sweets, and Anil sells sweets in small portions. Each portion has a mass of 25 grams, correct to the nearest gram. He sells 10 portions of the sweets, and we need to find the remaining one. Okay, so technically it is 600 minus 25 is for one portion, multiplied by 10, and this would give you the figure for remaining. But the question is not this. The question did not say calculate the mass of remaining sweets. The question is calculate the lower bound of the mass of remaining sweets. Now understand mathematics. You have a minus sign. When would you get the lowest possible value for this figure? When this thing would be its maximum. We need to find out the upper bound of this quantity, and then when I will do 600 minus the upper bound of this quantity, that would give me lower bound of the difference. Okay, now it's difference. If, for example, if I had A plus B, in that case, I would have said, for upper bound, I would have said upper bound of A plus upper bound of B. But this question was about lower bound. Let's say I had two quantities, I was adding them, and I was supposed to find out the lower bound of this sum, the lowest possible value of this sum. So in that case, I would have done the lower bound of A plus the lower bound of B. Okay, this is true for plus. But here we have a minus sign. Think about things logically now. Now imagine I have A minus B, and the examiner wants you to find out the lower bound of this quantity. So in that case, we would again, this, let's say this was fixed. Let's say this was 600. 600 minus B, and now lower bound of this quantity would mean you need to find out the upper bound of B, because upper bound would be a bigger number, and when you will take out this bigger number from 600, you would get a smaller number, right? So upper bound and lower bound totally depends upon the quantity. Like for speed, we just know that for fractions, if you need to find out upper bound of fraction, the numerator has to be greatest possible and the denominator had to be lowest possible. Similarly, for difference, and for finding out the lower bound, this quantity has to be the upper bound, because if this would be the upper bound, then I would be able to take a lot out from 600, and that would give me a smaller amount. If I say, instead of going for the upper bound, if let's say the question is again the same, calculate the lower bound of the mass. And if I start finding out the lower bound of this quantity, the difference would not give me lower bound. The difference would give me upper bound. Are you guys getting this idea?
Yes, ma'am.
And what about the other students? Kabir, Muiz, Taha, Hassan,
Yes,
Naz, Hassan, Sahal?
Yes, ma'am.
Yes, understood.
Okay, Urva and Osharwan, any question?
Miss, I don't get it for some reason.
One second. Okay, no problem. Obviously, it's fine. Okay, it's fine. Acha. First of all, let's forget about this part. Let's just, revise old contents. Let's focus on this statement only. Each portion has a mass of 25 grams. Now, this is your quantity, original quantity, correct to the nearest gram. When you do not have a number after nearest, it means it's 1. Okay. So accuracy is 1, and the error is going to be accuracy divided by 2. So this would give you plus minus 1 by 2, and it would be plus minus 0.5. This is just the error for this part. Okay. Acha. Let's find out the lower and upper bound of each portion. Okay. Lower and upper bound for each portion. So the lower bound would be original measurement, that's 25, minus the error, that was 0.5, and this would give me 24.5. This is the lower bound. And if I talk about the upper bound, so it would be 25 plus error, and it would be 25.5. Any confusions with this thing?
No.
Yes. Are you clear with this? I'm not sure who exactly asked this question, but is this okay now? Like the
That's me,
first
miss.
part? Okay, all right. This was just the basic idea. Now let's read the part. Calculate the lower bound of the mass of sweets remaining. How would you get the mass of remaining sweets? In total, it was 600. Remaining means minus. We had 10 portions. 10 multiplied by mass of one portion, that was 25. This would give you remaining, right? You had to find out the lower bound of remaining. Lower bound of remaining means this is a difference. In order to have the lower bound for difference, we are going to take the upper bound of this quantity, and for that I will go for 25.5. I will just use 25.5. Now this difference would be a lower bound. If I use 24.5, I know that the overall value would be more, and that would be the upper bound. Okay, so this would give me 600 minus 255, because 25.5 multiplied by 10 would give me 255, and then just do it without calculator. So 600 minus 255 would give you 345, and this is going to be the answer. So this part, and this part, this was direct. We had a quantity, we had its error, we were just supposed to add and subtract. This new quantity, the quantity that would give us the remaining mass of sweets, is basically a new quantity. I do not have an error for this directly, so I need to think about it logically, that it is a difference. For in order to have the lower bound of a difference, I have a minus sign here. The next quantity that is coming after the minus should be upper bound. Then the overall difference would give me lower bound. Are you okay with this, Hassan? Yes,
Yes,
Hassan
miss.
has. Okay.
Yes, sorry. Sorry, sir.
All right. Okay. Things would get better once we talk about the next questions. Don't worry about it. Acha, let's talk about the next one. Okay. Things would get better. That was just a first question. So forget it. Don't worry. Acha. Let me zoom in more. All right. Question number 19 was, a box has a mass of 1.7 kgs. This is your original quantity. Correct to the nearest 0.1 kgs. Now this 0.1 is the accuracy of the box of mass. Part A was write down the lower bound for the mass of box. That was simple. I had the original quantity, that was 1.7. For lower bound, I would just do 1.7 minus error. How did I find error? I did accuracy by 2. Where is accuracy? Accuracy is written right after the word nearest. That was 0.1. 0.1 divided by 2 gave me 0.05. And I had to subtract that. And overall, the answer was 1.65. So this was basically the lower bound for the mass of the box. Okay, let's talk about the next part now. The box holds 100 jars. Each jar has a mass of 140 grams, correct to the nearest 10 grams. Okay, calculate the lower bound of the total mass of the box and jars, and 100 jars. Give your answer in kgs. Okay. Calculate the lower bound of the total mass. Okay, so lower bound of the mass of the box plus the mass of 100 jars. Okay, now I'll tell you. Just look at it. Total mass would come by writing down mass of the box plus mass of jar, and this thing would be multiplied by 100. Okay, just give me 1 second. I need to add another student. Okay, again, the first part for this question was very easy. Things made sense directly. For the second part, now they want you to find the total mass of the box and 100 jars. And again, you need to think about it logically. Okay. So total mass would come once we add the mass of box and mass of jar multiplied by 100. That makes sense. If I talk about the lower bound of this quantity, that is the total mass, I need to have the lower bound of this and the lower bound of this. And then when I will add this quantity, that would give me lower bound. That makes sense. Obviously, I can't use upper bound of both these quantities, because if I will use upper bound of both these quantities, I would get maximum possible value. Lower bound means minimum possible value. For minimum possible value, I will be taking both the lower bounds for both the quantities, and then I would get the answer directly. 1.65 was the lower bound of mass of box. Okay, so 1.65 would come as it is, and now I need the lower bound of mass of jar. So it was 140 grams. For lower bound, we do original minus error. Okay, let's find out the error for this case. Error is accuracy divided by 2. And what is accuracy? Accuracy comes after the word nearest. It's 10. So 10 divided by 2 would give you plus minus 5. Plus minus 5 is my accuracy. So original was 140. Lower bound means minus error. So minus 5, and it would give me 135. So the lower bound of mass of jar would be 135 multiplied by 100, because the question was about finding the lower bound of the total mass of the box and 100 jars. So that is why I have an 100 here. And this is going to give me now very, very important part. This thing is in kgs, okay? And this thing is in grams. So good idea is to write down everything in grams first, and then I'll convert the answer to kgs, because the examiner said give your answer in kgs. 1.65 kgs means 1650 grams plus 135. I have 2 zeros, so I'll be writing down the zeros here. And now I can directly just add this up. 1650 plus 13500. Please do that on your own without using your calculators, because this would come in paper 1. And this is 15150 grams. Final answer has to be in kgs. So we need to divide the quantity by 1000 to get it in kgs. And this would give me 15.15 kgs. 15.15 kgs. I'll explain this again, and then if you have queries, you guys are more than welcome. Okay. The first part was very easy. For the second part, let's read the main question. You had to calculate the lower bound of the total mass of the box and 100 jars. Total mass would come when you will add the mass of box and mass of 100 jars. For lower bound, you had to find the lower bound of this quantity and lower bound of this quantity. 1.65 was already calculated in the previous part. This was in kgs, and 140 grams was the actual quantity, and we had to subtract the error for finding out the lower bound, and this gave me 135. Why did we multiply it by 100? Because we had 100 jars, and this 135 was the lower bound of one jar. Okay. Finally, I had to simplify. Now I can't add things directly when one quantity is in kgs and the other quantity is in grams. I need to have all the quantities with the same units. So 1.65, when I will convert kgs to grams, I multiply 1000. So 1.65 kgs is equal to 1.65 multiplied by 1000 grams. And this gave me 1650 grams. Those who are not clear with the conversion, this is for you. It's 1650 grams plus this came directly. And after adding, I got this figure. Now this was in grams, and I was told that the answer has to be in kgs. So to convert from grams to kgs, I divided that quantity by 1000, and it gave me 15.15 kgs. Yes, now tell me if you have any concerns, any queries, anything, just ask me. Abdullah, Ariba, Hassan, Sahal, Kabir, Muiz,
Yeah,
Taha,
clear,
Uba.
clear. It took me some time, but I got it.
Okay, perfect. And it would get even clear once we talk about more questions. Okay, so I hope that you guys are being honest with yourselves and you're telling me honestly that you have understood this part. That's perfect. Let's talk about another question, and then things would make even more sense. Okay, I'll just explain the question and let's see if you guys are able to do that or not. Okay. A car has a mass of 2400 kgs, correct to the nearest 100 kgs. A caravan has a mass of 1460 kgs, correct to the nearest 10 kgs. Calculate the lower bound for the total mass of the car and caravan. It's very easy. You guys can do that. Please try doing it and then I'll ask you. Once you're done, just type your answer. Do not tell your answer directly, just type your answer. Yes, students, please try doing it. Take a few more seconds. I just got 2 answers so far. Very good, Taha. Your answer is correct. Excellent. Okay, all right. Let's try doing it together then. Okay, no problem. Okay. A car has a mass of 2400 kgs. Correct to the nearest 100 kgs. 100 kgs. A caravan has a mass of 1460 kgs. Correct to the nearest 10 kgs. Okay. Calculate the lower bound for the total mass of the car and the caravan. Again, for the total mass, I need to have the mass of car plus mass of caravan. Okay. For having the total mass, I need to have the mass of car and mass of caravan. And for lower bound, again, it's a plus sign. Think about it logically. When would you get the lower bound of this quantity? It's very simple. You would get the lower bound of this quantity once you have the lower bound of this quantity and once you have the lower bound of this quantity. Okay. So lower bound for the car mass and lower bound for the caravan mass. Okay. Now we know that we need to find out the lower bounds for the mass of car and for the caravan mass. Okay. Lower bound is basically original, that is 2400 minus error. How do we find error? Error is accuracy by 2. What is accuracy? Accuracy comes after the word nearest. After the word nearest, we have 100 kgs. So it would be minus 100 by 2. 100 by 2 is basically your error. This is your error. I'm doing it directly. So 2400 minus 50 would give you 2350. This is the lower bound for the mass of car. 2350 plus the lower bound for the mass of caravan. So lower bound is original, that is 1460 minus error. Error is accuracy by 2, and that would be 10 divided by 2. And it is going to give you 1455. Okay, so 10 divided by 2 is 5. And when you will subtract that, it would give you this. So it's 1455. And now when we will add both these quantities, it would give you 3805 kilograms. So this is how we do it. The error and the accuracies would be given for two quantities. For difficult parts, the third quantity would basically be made using the two quantities given. So for that case, you need to think about it logically and then things would make sense. Okay. Any confusions with this? Urva, is it clear now?
No confusion.
Okay,
Ma'am,
perfect.
why is the error not 0.5?
Okay, very good. I'll tell you. For the caravan,
For both of them.
okay, I'll tell you. What is error? Error is accuracy divided by 2. Okay. Urva, what is the accuracy for the car? Look at this. Accuracy is basically written after the word nearest. That's just my way of explaining this. So it's nearest. After nearest, what is the number? The number is 100. So the accuracy for mass of car is 100. It would be 100 divided by 2 and it would be 50. This is for the car. If I talk about the caravan, again, accuracy, error is accuracy by 2. And what is the accuracy for caravan? The word nearest has a 10 after it. Okay, 10. 10 divided by 2 would give you 5. So for every quantity, the accuracy and the error would be different, and we find accuracy by looking at the number written after nearest. Okay, this time around, I agree we did not have a figure directly, but still it said 100 kgs or 10 kgs. So 100 means 100 and 10 means 10. Okay. Yes, is it okay now? Please remember, the accuracy is not, the error is not going to be 0.5 for every scenario. That totally depends upon the measurement. Yes, Urva, understood?
Yes, ma'am.
Okay, perfect. Okay, let me see. I think I have another example. Yes. Okay. One last question for today. Let me see. Yeah, it's one last question. All right. Okay. All right, let me just erase this. We have this thing written because we have done this example already, but let me just do it again just so things make more sense. Okay. Again, this is the last question for this chapter, and then you would be tested for this in the quiz on Friday. So if you have anything that's coming to your mind, just tell me directly. I can explain that to you again as well. Okay, anyways, let's discuss this first. The length of a path is measured as 62 meters. Okay, this is the original measurement it's given. This is original. Correct to the nearest meter. Nearest, after nearest, I just have meter. It means nearest meter means nearest 1 meter, right? Nearest kilometer means nearest 1 kilometer. Nearest liter means nearest 1 liter. So it's 1. So my accuracy is 1, which means my error is going to be 1 divided by 2, which would mean it would be plus minus 0.5. Write down the upper bound for the length of the path. Upper bound is going to be the original length, that was 62. For upper bound, we do plus error, and it would give me 62 plus 0.5, and that would be 62.5. Okay, so this was a simple part, and that is why it was for 1 mark only. Very good, Taha. Well done. Okay, the next part. The mass of a bag of peanuts is 80 grams. Okay. Original. Correct to the nearest 10 grams. This is your accuracy. Calculate the lower bound for the mass of 5 of these bags of peanuts. Okay. So we have information about 1 bag. You need to find out the lower bound for the mass of 5 of these bags. So it would be the lower bound of 1 bag of peanuts multiplied by 5. Since it says lower bound, I'll just write down the lower bound of this quantity and then I'll multiply that with 5. So what exactly is it? The original for this case, the original measurement for this case was 80. My accuracy is written after the word nearest, that is 10. My error is going to be accuracy divided by 10, so it would be 5. So the lower bound for a bag of peanuts would be original minus the error, so it would be 75. Okay, so I'll do 75 multiplied by 5, and this is going to give me the answer, and that would be 375. Okay, so again, this part was easy comparatively. You were supposed to find out the lower bound of something that you were multiplying with a constant. So constant would remain constant. I cannot find the lower bound of 5, it's just the number. So it would remain 5, but we can find the lower bound of the bag of peanuts, and the original measurement was 80. The error was 5. So I was just supposed to do 80 minus 5. That gave me 75. So 75 multiplied by 5 would give me 375. And this is the lower bound for the mass of 5 of these bags of peanuts. Yes. Now tell me, anything that's coming to your mind? Very good, Taha. Your answer was correct. Yes. Any student, any concern? We are done with what I planned for this lecture. So now I can address your queries.
No confusion.
Okay. Very good, Taha. Abdullah, Ariba, Hassan, Naz, Hassan, Sahal, Urva, Noshavan.
No, ma'am.
No confusion, ma'am.
Okay. All right. Okay. Abdullah, understood?
Yes, ma'am.
Okay. All right, perfect. I keep on asking this because at times some students are shy. They don't. Yes.
Ma'am, I have a question.
Yes.
Ma'am, the upper bound for error, ma'am, for the upper bound for error, we have to add 0. For this question, ma'am, we will have to add 0.5, right?
For the first part. For the first part. For the second part, the error was different. Okay.
Okay, ma'am. But if we add 0.5, then when we are rounding it to the nearest meter, we will actually get 62.3, right, ma'am? So it does not make sense.
No. Wait. I'll tell you. Look, if you're talking about the first part, it's the upper bound. We find the upper bound by, you're not supposed to round off anything here. Okay. You're not supposed to do that thing here. You just know this was your original measurement, that was 62. For upper bound, we do original measurement plus error, and error turned out to be 0.5. This is your final answer. You're not supposed to round it off. This figure was basically rounded off, but let's not go there. For upper bound, you just need to add the error in your original measurement to find out the maximum possible value. For example, let's say you were measuring something and the error can be plus minus 1 meter. So let's say you measured that length to be 62. If the error was 1, in that case, your maximum possible value or the upper bound would be 63 and the lower bound would be 61. Okay, so upper bound and lower bound is just this. You're not supposed to round off anything. No, you're just supposed to find out the maximum or the minimum possible values by adding or subtracting the error. That is it. Okay, once you got 62.5, that was the answer. You're not supposed to round it off, and 62.5 would not give you 63.3. 62.3. Are you getting this thing?
Yes, ma'am. So rounding and finding the upper bounds and low bounds, they are not related, are they?
No, I'll tell you. Rounding off is a completely different thing. You'll round off answers. You'll give your answer up to a specific number of significant figures or decimal places when the examiner would tell you. Whenever the question is about finding the upper bound or the lower bound, you're not supposed to round off anything. Okay. If it's upper bound, you just take the original measurement and you add the error. If it was about lower bound, you'll just take the original measurement and you'll subtract the error. You're not, so I agree. I agree. This statement right here would have, made you think that you were supposed to round it off to the nearest meter. No, that's not true. The statement says the length of a path is measured as 62 meters correct to the nearest meter. Like this 62 meters was basically rounded off. This was basically the idea. This 62 was rounded off. You're not supposed to round off anything. This is a rounded figure that the examiner gave you. You're not supposed to round off anything when the question is about upper or lower bound. No. Okay.
Yes, ma'am.
Sure that you have understood this?
Yes, ma'am.
Okay. All right. Let me stop the recording.